Alright, good day everyone, wherever you're watching me from. You are welcome on this channel. Today we're going to be looking at reinforced concrete design, and we're going to be looking at a topic called limit state design. First of all, my name is Michael Israel. Alright, quickly I will just take you through what we call reinforced concrete design. So today we're going to be looking at limit state design. I am Michael Israel Ifani. Without wasting much of our time, we'll quickly run you through what we call reinforced concrete design. Please, if you have not subscribed, subscribe to this channel, like, comment, so when we release videos like this, you begin to see them, you get notification when you subscribe. Alright, please just click on the red bell button to subscribe. Thank you. Let's ask, what do you understand by reinforced concrete design? Reinforced concrete design is a structural engineering approach that involves combining concrete and steel to optimize the performance of a structure. I'll go over it again. Reinforced concrete design is a structural engineering approach that involves combining concrete and steel to optimize the performance of the structure. Steel is added to enhance its tensile strength, as concrete is good in compression but weak in tension. Concrete is good in compression but weak in tension. So to enhance that tensile strength, we introduce for the tensile forces. Alright? So we're going to be looking at the design process. The design process considers factors like load bearing requirements, material properties, and safety standard to create structural, sound, and durable buildings or other infrastructures. Good. So basically, this is what reinforced concrete is: combination of your steel and your concrete finish. Now, it comes to what they call limit states now. Now, in limit state, but before we look at limit states, in design, there are different codes of design. Number one, we are in a British colonized country where we use more of BS code. BS code is British Standard, BS 8110, Part 1, 1994. This is a code. This is BS 8110, Part 1, 1991. Then also, we have another one called EC2. EC2 is Euro Code 2. We have American codes, we have India code, we have many types of code. But for this course, we're going to be looking at BS 8110 Part 1 1997 and Euro Code 2 and other relevant code if need be. Alright, so for now, let's go to limit state design. Limit state design. Now, what do we understand by the word limit state? Limit. Alright, so limit state design of an engineering structure. Limit state design of an engineering structure must ensure, number one, under the worst loading, the structure is safe. Under the worst loading, the structure is safe. 2, during normal working conditions, the deformation of the members does not detract from the appearance, durability, or performance of the structure. Now, what do you understand by the word members. We have members, let's say your slab, your beam, your column, your foundation, your staircase. If possible, a wall can also be a member depending on what you're designing for. Are we there? Alright, so basically those are things we're going to be looking at. Say, under the worst loading conditions, like no matter how the loading can be, as far as you have designed it, your building must still be safe. The lives of people occupying that building must be saved. During normal working condition, your members must not detract from their appearance. They must still remain intact. Alright, that's for that. That will take us straight to the methods of limit states. There are three basic methods of limit states. Number one, let's look at method. Permissible stress method, load factor method, limit state method. I'm going to be taking them one after the other. What do you understand by permissible stress method? Now, before I will explain this, there's what we call partial factor of safety. Let's look at what partial factor of safety is before we come back to these three. What is partial factor of safety? Partial factor of safety is a factor that you apply to your materials or your load. Let's say, for instance, we have permissible stress method. Permissible stress method, which states that you should apply your partial factor of safety to the ultimate strength of the material by dividing. Let's look at it here. So the permissible stress method in which ultimate strengths of the materials are divided by a factor of safety to provide design stresses, which are usually within the elastic range. That means this we are talking about when you have your partial factor of safety and you have your characteristic strength of material, either for steel or for concrete. Then you divide by partial factor of safety. So this is the partial factor of safety for steel. So let's go for concrete. Let's go. I have this for concrete. I have this. I hope we are fine with this. All right. So let me move down to the next one. So let's say, for instance, now what permissible limit state is saying is that if I should have a material, basically this is permissible stress method. This permissible stress method, when you apply partial factor of safety to a material by dividing, that gives you permissible stress method. So let's look at load factor method. Let's look at load factor method. You can copy this. If you want to, you can copy this. Load factor method states that when you apply partial factor of safety to material by multiplying it, that is load factor method. When you're going to apply your partial factor of safety to load, just like you are increasing the amount of load that you have. Let's look at load factor method. Load factor method is when you apply partial factor of safety to your load to give ultimate load. The method is saying is this. Let's say, for instance, let N equal to ultimate load. So N will be equal to 1.4 GK plus 1.6 QK. So the factor for dead load is 1.4. Factor for life load is 1.6. That shows you are increasing your dead load by 1.4 and also increasing your life load by 1.6. This 40%, this 60%, 40% of 1 is 0.4. When you add it to 1, it should give you the increment. You can do that math. Alright, let's go. In Euro code, they gave a tolerance of 1.35 to dead load and 1.5 to life load. But for BS code, it's 1.4 and 1.6. Alright, so depending on the code that you are using to design, it varies. It varies. It varies. So what this is basically load factor method. Load factor method, when you multiply the partial factor of safety by the load you already have. As for that. So this is the second method also. This second method, this is load factor method. Why this has not been in use is because there's a lapse between permissible stress method and load factor method. Permissible stress method only apply a partial factor of safety to material without putting in consideration the load. The same thing, the load factor method did not mention anything about material. It only talks about load alone. But the one we're going to be looking at that is in existence now, that we make use of now, is the one that talks about the load and also talk about the material. That takes us to what we call the third method, which is limit state method. Now, what is limit state method? Limit state method is when you apply a partial factor of safety to your load by multiplying, and also apply partial factor of safety to your material by dividing it. That is limit state method. So what we use currently now is limit state method. It has override your permissible stress method and load factor method. Thank you for watching. Once again, that your limit state method is a combination of your permissible stress method and load factor method. That is all for method of limit.